Okay, so welcome to the WasmEdge community meeting. And today we have two topics. The first topics is I'm going to introduce application called WasmEdge Android. It's an Android application that can package your Wasm application, package your LLM model, and your OpenAI compatible server into a single Android application and install it on your smartphone and run it. So this is our first topic. And the second topic, I believe that's why there are lots of people here, is to talk about the 4 topics we have during the LFX mentorship turn 3. So I'm going to share my screen to talk about the WasmEdge Android app.
So we have a project called the WasmEdge Android app, and basically you will you just need to set up your Android home and your NDK here, and all you need to do is to compile it with the hardware you have. For example, if you are on on an old Android platform, you may need to change this value from 28 to an old one, or you want to have a new one, you just upgrade this version here. And after you build it, you will need to copy the following files to this AC folder. The reason is that we are use a runner that can run these following files to load your LLM model and create a server for it. So after that, since we are not implement a downloader inside this app, so you have to manually download your model here. So for example, we are using a Geometry 1B, the model. So you download it and just put this model under the same assets folder. And then you build your Android app again and use ADB to install your application. So here is how the execution flow. So after you create your app here, and you just need to install it, and when it is code is start, you can see here, and the Llama Edge server it will be run. And after that, you will create web UI here under the localhost 8080, and you just interact with it. Of course, you can have your own other applications just connected to this URL. For example, you can connect to the localhost 8080/v1. I believe this is the same endpoint, just like you are using the OpenAI endpoint. So the first part I want to share is we have this sample project. So if you are interested to run any of your AI application, want to run any model with WasmEdge on your smartphone, you can just fork this project and just change the model or change the Llama Edge server here to any application you create, just to overriding it. And then you will have your own Android application to execute this AI workflow. So this is the first part of our topic. If you have any question, you can just leave comments under the chat and I will answer it. So this is the first part. And let's move through the second part here. So when you want to apply the LFX mentorship, you can figure out that with this label LFX mentorship, and every time when we create a new project idea, it will just like this format. For example, you can see the LFX mentorship, which turn here and the title here. So after that, we have 4 topics during this turn. So let me just introduce by projects to let you guys have a basic idea of the project is going to do. So the first one is that we would like to apply the pointer alignment checking for all arguments, including the WASI host functions. So if you check this description, basically it's talk about that there are lots of WASI functions, and the arguments inside these functions may be a pointer type. However, we didn't check the alignment. So if the alignment is mismatched, we should trigger a trap. However, we didn't before. So this project idea is going to analyze all of the WASI proposals and to check if the type is a point. And you have to also check the alignment. So because this you need to contribute into the WasmEdge project. So basically, we hope you have the C or C++ programming language ability, and also you will need to understand what is WebAssembly, what is the WebAssembly system interface, the WASI part. So it will help you for a better understanding of what we want to do and how to do that. So if you want to apply it, here is the apply link. You can just click in and submit your resume and any material here. Also, we have a pretest. So you have to, clone the WasmEdge repo, and you just select one of the WASI function. So basically, all of the host function body is under this path. You just open it and just choose any one of it. And you have to, read these alignment requirement and write your code to do a check on this selected function. It's just a demonstration that you have the basic idea to finish this project. And you should show your code change here or by link. If you don't want to publish your code under these issues, you can just create a link and just attach to your resume or your material. That's fine. We will just check the link and to see if you finish this pretest or not. So this is the first part. And for the second one is that we have a new installer to install WasmEdge. So this project is called the WasmEdge app. And we actually have 3 installer before. The V0 is deprecated, and the V1 is the Python base. And lots of people say they don't like Python. So we have the V2 version, which is the bash based. However, they are not fully cross-platform because we want to handle the Windows platform, the Linux platform, and the Mac OS platform at the same time. That's why we created this new tool called WasmEdge app. So we already have some feature implemented under this project. So if you are going to apply this mentorship, you will need to support the following features, including the remove function and the plugin mechanism. For example, you need to you have to implement these 3 subcommands is to list all plugins and install some plugins and also remove some plugins. And there are lots of hardware or system features we didn't detect by the WasmEdge project, but we did them before in V1 and V2, which is we will detect if your environment is CPU only, or do you have the AVX instruction set, or do you have the CUDA, and what version of you have the CUDA. Also, if you are on a AMD GPU, for example, you install the RCM, and if your environment have OpenCL or something like that. So the reason we want to detect these features is because when you want to run an AI model, if you have GPU, you must enable it to a better performance. So that's why we have to make this installer to do these checks here. So if you are not familiar with this project, please just go to the WasmEdge project and just interact with it. So we also have a pretest here. You must build and execute and verify the current WasmEdge app on your own system, because we believe it's a cross-system application, so it should be fine if you are using Mac or using Linux or using Windows. That's fine. However, you have to prove that you can build and run it. Also, if you already have some cool Rust projects, or you have some contribution, for example, to the Rust toolkit or something like that, you should include all of them in your resume. And or you want to just attach a link under your resume, so we can check your contribution before. Yeah, that's the pretest of this project. And we have the remain two, and I believe Michael can talk about that. So let me hand over to Michael. Hello, Michael. Are you speaking now?
Can you hear me?
Oh, yeah. Please go.
Yeah. I don't know what's wrong with my headphone, but anyway. So yeah, like Hydai said, we have 4 mentorship opportunities, and so Hydai has covered 2 of them. Those are more related to the basic software infrastructure, right? That's directly related to our runtime automation or things like that. And the 2 that I have are the ones that are more related to the applications and more continuation of the past mentorships program that we have proposed. So we had 2. So I had 2. So one of them is called it's issue 4284 if you go to our GitHub repository, and it's called the Rust decoder for cloud code, right? So the Rust decoder project has been we have 2 past mentorships that are working on that. So basically, the idea really is that one of the major use cases of WasmEdge is to use it to run large language model, right? So and one of the major use cases of large language model is to do coding assistance. So so we want to build demonstration applications to show people that that we can use WasmEdge to build a coding assistant using open source large language models. And as you can see already, there are quite a number of open source large language models that are very good at coding. For instance, Mistral have a model called DevTrail, and Llama had a model called Llama Coder, right? So there's the open source world has definitely been building better and better coding models these days. So I think from almost a year and a half ago, we started this journey of trying to do coding assistant for Rust, because most of the coding, LLMs out there are mostly focused on Python or JavaScript for very good reasons, because they have the most training materials out there in the internet, right? So so they have seen the most Python code, so they tend to write Python code, and but Rust offer a very unique advantage. So I talked about that in one of my recent talks. Is that and I think people are increasingly recognize that is that Rust, although there are not a lot of Rust code on the internet, but Rust provide a closed feedback loop for the large language model. So meaning that as soon as the large language model generates any Rust code, you can use the Rust compiler to verify it. That creates a feedback loop, and that allows the large language model to improve much faster than it can improve on Python code, because once you generate a Python code, and then someone has to run it, and someone has to interpret the results, right? But if you generate Rust code, then there's a very strict compiler it has to pass. So we have been building around this idea, to have better better Rust support in those coding tools for a while. So this new LFX mentorship opportunity, extends this the work that we have done by two mentees in the past. So we had built a large knowledge base for Rust, meaning question and answer, common errors that we see in Rust, and common application templates that you can build in Rust, and things like that, right? So as you can see, there's links to the previous work that we have done. So that's so the knowledge base basically allows us to build a vector database that can, whenever the user asks a Rust-related question, be able to find relevant answers and provide that to the large language model so it can, can answer those questions better. And in the second iteration of this project, we did an MCP server. So if you, I don't know if you're not familiar with AI world, what's MCP? It's called Model Context Protocol, which is a really popular way to adding tools to large language model. And in this particular case, we're adding the Rust compiler as an MCP server to the Rust to the large language model, right? So we did a project like that. So in this new proposal, we want to take it a step further and to address a very I think a very popular or very in-demand use case. That is, I have say, people have projects that read in Python. Many of those are AI projects, or they have utility or infrastructure projects that read in C++, right? So the Rust community has always wanted to rewrite those in Rust, right? So I think I actually do think there's a lot of value in there, because if you look at organizations from Microsoft to the U.S. government, they all have guidelines to say, a new project should be written in Rust. You shouldn't start your project in C++, for instance, in Microsoft, right? So there's lots of demand for not only using Rust to do new projects, but also to make the older projects safer. Right? So the idea really is that to make this tool more friendly to humans, because we have already seen what's a good coding assistant look like for humans. Those are cloud code, right? That's once Anthropic has released the cloud code, everyone sort of starting, mimicking it or copying it. So Google had Gemini code, or Gemini CLI or whatever. It is almost exactly the same clone of cloud code, and Llama also had a clone, right? Llama code. So there's a So I think we are pretty much settling on the standard user interface for large language model-based coding assistant. So that is, Cloud Code has really built an example for us. And the really good news is that it's all open source. So, so the mentee in this project would take Cloud Code, and then we can accept both two approaches. One is to fork it and to build something new on top of it. So for instance, Llama and Gemini, Google both did that. They basically forked the Cloud Code. But perhaps a more friendly or more community-driven way is to try to find a way to add on to it. So I'm not really sure which way we should go, but I think we should experiment with forking it and adding features to it first, right? And once you fork it, you can build workflows. So for instance, instead of giving it a prompt to say build an application for me XYZ, and here's a plan, generate a plan, the standard ways you do web coding, right? Instead of that, you should allow user to say, here is a project that I want to rewrite in Rust. Okay, give us the GitHub repository, and then you find then you use the Rust coder tools that we have built in the past to extract all the source code and documentation from that GitHub repository that you want to pull. That could be a Python project or a C++ project, and organize all those contents into a prompt or context, right? And then figure out how you feed that context into the large language model, and what prompt are you going to use to make it generate Rust code. And then that's, I think, would be interesting, is to take the MCP server that we built, or you can build your own, because MCP server isn't that difficult to compile the Rust code. Or, maybe it is not, in the context of Cloud Code, it may not be necessary to use MCP to do the compiling, because the compiler is probably already available in the Rust code environment, right? In the Cloud Code environment. So you would allow the user to compile it, and then which I think Cloud Code has a lot of those utilities already set up for you. So you can take the error message and keep doing it until you get a passing, you get to complete it past the compiler and then generate the artifacts, right? Then you can also do an MCP server to run the Python or the original program. The original program could be C++, and you can actually download all the check out the GitHub repository, and then build and run it, and then build and run the Rust program and see if the results are the same. So yeah, that's that may perhaps require you to the user of the guide the large language model, write some test cases and things like that. So there's lots of things that you can, as you can imagine, there are lots of things that you can do. So we're gonna, I think within this week, we're gonna have some pretest, just to make sure that you understand how we get here, and you understand how to modify Cloud Code, and you understand how to, how this whole process gonna work, right? But I think this is one of those, higher impact projects, because this address a real need, right? So yeah, that's so that's the Rust Coder project, and if you have questions, you can ask, or you can put that in the comment. So let me check if there's any question in the comment. Okay. Okay, no, okay. So I'll go on to talk about the second project that we have, which is also AI related. That's to add the new response API to Llama Nexus. So for this project is actually more straightforward. It requires less research than the Rust coder, because the goal is very specific. In order to explain this project, we have to explain what is Llama Nexus. So Llama Nexus is something that you can loosely consider it's like the open router. So it's a proxy server, okay, written in Rust. It's a very simple proxy server, and so the upstream from the proxy server is provide APIs for users, And the downstream from the proxy server are any of the large language models, be it the commercial large language model from OpenAI or Anthropic, or locally hosted large language model, for instance, Llama Edge, right? And it could also has multimodal models like voice to text, text to voice, and things like that, and text to image, and things like that. So so on the downstream, it could have any number and any combination of those models and services. But on the front end, it provide a unified OpenAI compatible service. Okay, so you start a Llama nexus, and you could say that the chat completions, meaning that's to answer text questions, goes to Gemini. To the text to image goes to Llama Edge running Stable Diffusion. The text, the voice to text goes to say Assembly or 11 Labs, those one of the specialized voice providers. And from the user's point of view, when they are interacting with Llama Nexus, all they use is the open source, is OpenAI API. Okay, so you could have a large number of things on the backend, and they could be from all kinds of different providers in all kinds of different APIs. But from the value Llama Nexus provide is that it's providing unified API for the user on the front, right? So that's what Llama Nexus is. That's so far so good, right? However, as those APIs become more complex, one of the most common features that we get for Llama Nexus is to can you guys build an MCP in it, right? Tool calling. And we did that, meaning that's in the Llama Nexus proxy, you can register MCP servers or tool calls. And so when users say chat completion, they will get an assistant answer that has gone through the tool call process, meaning it's not an answer that the large language model directly provides. It's the large language model would say, I want to call this tool, and then Llama Nexus call the tool on the on the user's behalf, and then send the tool result back to the large language model, and then have the large language model come up with the answer, right? That's fairly standard way of using MCP and tool calls, right? So, however, if you look at OpenAI, they have the same kind of challenge. They also have a proxy in front of their different models. They have a proxy in front. They have models like the different large language model and images and things like that on the back end. So they have came up with a new API called Response. The Response API turns the stateless large language model into a stateful API, meaning that you no longer have to attach the whole history of the conversation, the system prompt, the past conversation history, and things like that. You just give the proxy or the system the current question the user asks. The proxy or the system maintains the database of what's being asked in the past. How should I respond to that? And in that process, it also maintains the tool calls. If I ask what's the weather in Austin, Texas right now, it knows to look up the weather.com API and then come back with the result and then speak it, right? It also knows if I ask it a day later, the weather request that I made yesterday is not valid anymore because that was because the weather changes all the time. So you need to make a new API call. So it maintains all this state in the database. So the response API is fairly well documented, and so the goal of this project is really we already have a lot of APIs implemented in Llama Nexus, is to add to this work to implement the response API. And the pretext, the pretest, which we're gonna, I think again, we're gonna publish this week, is to make sure that you actually understand all the things that I talked about. What is chat completions? What is called the large language model stateful versus stateless? What is the MCP? And how do you construct the prompt, right? So what we're gonna do is that we're gonna ask you to implement the simplest form of the response, meaning that's every time when the user asks something, it's gonna ask the current question without attaching the past history. And in your implementation of the response API, you would have, say, a conversation ID and embedded database, probably a SQLite or you can connect to a cloud database. I don't really care. That's so to have some kind of persistent storage where you can manage the conversation history, so that I can, as an API user, I can just send in the API request, and you're gonna provide the stateful answer from the large language model back to me. So that's so I think that would be the pretext. That's we're gonna ask you to the fork the Llama Nexus project and add this API into the implementation, and you can keep this as a private repository, so that that's so you can submit to us and show us your work, right? Or you can you can keep it open source. That'd be great as well. And or you can open source it after the pretest as well. So yeah, there's a number of ways to do it. So yeah, that's those are the two projects for me. And let me see. Okay, so there's a question: is it possible to host web apps or train models? Well, that's a question for Hydai then. Okay, I think okay, he answered. But that's it. That's the pretest is going to be published on the GitHub repository. So so we don't have private messages. That's so it's going to be published later this week. When LFX started their application process, we'll publish the pretest. There would be no extra time. That's this is all very standard deadlines for the large for Linux Foundation. So Hydai, you can go on.
Okay, so let's off our topic, and I will wait for 5 more minutes. If you have any question, you can still leave your questions under the chat, and I will answer it. If not, we will just end this community meeting after 5 minutes. Thank you, everybody. So let me try. I want opinion on this issue. Let's still double IP. Let me check the issue here. I just want to be sure if the approach is right or not. I will leave a comment under your issue because I'm not sure, but I cannot. So let me share my screen. You will understand why I have to. I have no idea, but this link just give me 500 error. So I will leave comment under your pull request after the community meeting. Sorry about that. Is it possible to use the Android phone as a server and expose the server applications via internet, but not only the mobile user? Also, will it be possible to have kind of P2P communication Android applications with WasmEdge of internet? I believe is possible because we did expose the port to AT&T, but you may need to check if your Android system have some security policy that's banned some connection from outside of your devices. I'm not sure if there is a firewall or is a security policy that is guaranteed by your Android application system. However, if they don't, then it should be fine to to create your services and just let any devices connect to your server application.